Okay, 9.5, we're working on the sine and cosine ratios. Remember, we're working with sine, we have cosine, and we have tangent. And we have this little phrase, it goes, so, toa. And right now, today, we're going to be working with sine and cosine, where we have O and H, so we have opposite over hypotenuse. That's the so opposite hypotenuse. The cosine is ca, so A over H, adjacent over hypotenuse. And that's what we're going to be working with today. This first image, right, the sine of A, here's just a good example. Sine of A, we go opposite over hypotenuse, so we have this line here, BC, the length of BC over the hypotenuse AB. The cosine of A is adjacent, so AC, over that hypotenuse AB. Okay, we're not going to do this, we're going to skip through it. We're going to go right here. Okay. These definitions, again, you can write them if you'd like. I'm going to get my book out and see the exact definitions here. Okay, the sine and cosine, both of these, are ratios that are trigonomic ratios. So what ratios are going to say? Trigonometric ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. Okay. The trig ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. The angle of depression. Angle of depression is the angle that a downward line of sight makes with a horizontal line. Okay, so in my last lesson, I drew a plane. Okay, here's my plane. Here's my wing. This angle of depression, we have this horizontal line right here. If I was looking down at this person, here's me. Okay, it'd be this angle here. I'm at, let's just say 40 degrees. That's my angle of depression. Okay? Sine and cosine ratios. Okay, we went through that at the beginning. Sine and cosine of complementary angles. The sine of an acute angle is equal to the cosine of its complement. So the cosine of an acute angle is equal to the sine of its complement. We'll get into some examples here down below. All right. First, we're going to do these exercises 1 through 3. We're going to find the sine of f, the sine of g, the cosine of f, and the cosine of g. So let's start with f. The sine of f. That equals, remember to go opposite. So what's opposite of f? It's 12 over 13. Okay, we have to find the sine of f is 12 over 13. Okay, so if you type in the calculator, where's my calculator? Right here. You say 12 divided by 13, you get 0.923. And it's equal to 0.923. Okay, now let's find the sine of g. This angle. That is equal to 5 over 13. Okay, if you just type that into a calculator, 5 divided by 13, you get 0.384. Okay? Now, let's find the cosine. I'll do it in blue. The cosine of f. Remember, that's adjacent. 5 over 13. Cosine of f is equal to 5 over 13, which is equal to 0.384. Cosine of g, or adjacent over hypotenuse, is equal to 12 over 13. 0.923. Okay, number 2. I'll just do the sine and cosine of 1. So I'll do the sine of f is 65 over hypotenuse 97. Okay, that's the sine of f. Okay, how about the sine of g? The sine of g, remember, we have to go opposite. So 72 over hypotenuse 97. And I can let you do the cosine of those if you'd like. I'll do the cosine of these over here. So cosine of g, you have to do the cosine of g is adjacent, so square root of 2 over 2, over the hypotenuse 2. The cosine of f, remember adjacent, so square root of 2 over the hypotenuse 2. Down here in exercises 4 through 6, write the expression in terms of cosine. So we have the sine of 9. Remember, if I scroll up here, the sine, actually we're going the cosine right here, the cosine. Cosine of a, or sorry, what are we working with? I have to scroll down, check out my problem. We're doing sine. So the sine of 9 is equal to the cosine of 90 minus 9, which is equal to the cosine. Oh, what's 90 minus 9? 81. Okay, so that's actually my answer for number 1, or for number 4, the cosine of 81. All we're doing is we're taking 90 minus what they have for degrees. So what's 90 minus 30? Cosine of 60. Okay, and this one, 90 minus 77, it's the cosine of 13. Okay. Number 7, down here. Cosine of 15. So the cosine of 15, going back up here, the cosine of 15 is equal to the sine of 90 minus 15, which is equal to the cosine of 75. Oh, sorry, not cosine. The sine. The cosine of 90 minus 15 is the sine of 75. Okay, how about B? All we're doing is we're taking 90 minus 83. So the sine of 7. And the sine over here, 90 minus 45 is 45 degrees. Okay. Down here, number 10. Find the value of each variable using the sine and cosine. Round your answers to the nearest tenth. Okay, so the sine of 16 degrees is equal to x over 9. Okay, so we have to multiply 9 by the sine of 16 to get our answer. 9 times the sine of 16 equals 2.48. So x equals 2.48. Y, on the other hand, y, let's go adjacent over hypotenuse. So the cosine of 16 is equal to y over 9. So you have to multiply 9 by the cosine of 16. We get 8.65. So y equals 8.65. Number 11. Number 11, we could do the cosine, or the sine, let's do the sine of 72 degrees. And we go opposite, so n over hypotenuse, which is 50. So 50 times the sine of 72 equals 47.55. And I know it says round your answer to the nearest tenth, so we can do 47.6. That's to the nearest tenth. Let's find m. M. We can take the cosine of 72. That's going to equal m over 50. So we're taking 50 times the cosine of 72. That's going to equal 15.5. Down here, we could take and find the cosine. Let's start with the cosine because we don't know opposite over hypotenuse yet. Okay, so we're going to take the cosine of 47. And that's going to be equal to 10 over d. And if we cross multiply, we get cosine of 47d equals 10. We have to divide, so we're going to take 10 divided by the cosine of 47, and that's going to get us d, which is 14.7. So d is equal to 14.7. And c, we can take the sine of 47, set that equal to c over 14.7. We're going to multiply this times the sine of 47, we're going to get 10.7. So C equals 10.7. I'll let you guys do 13 on your own. Down here, 14. a camera attached to a kite is filming the damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. So we have our closed-off area. Here's the camera up above it. The person is standing 100 feet away from the center of the closed-off area. So we know that this is 100. The angle of depression from the camera to the person flying the kite is 25 degrees. So this angle here is 25 degrees. Okay. How long is the string on the kite? Okay. Sorry, I'm going to rewrite this. Here's why. We have our center. Okay, we have our person standing 100 feet away. That's good. 100 feet. Okay, the kite is up here. Makes this angle. We're wondering how long that hypotenuse is. We're wondering how long the string is. But this angle of depression is right here, actually. This 25-degree angle of depression. Okay, and this makes a right angle. So if that makes a right angle, what is this angle right here? We take 90 minus 25, right? So that's 65 degrees. So how do I find the length of the string x? Well, the sine of 65 is equal to 100 over x. So on my calculator, I got to take 100 divided by the sine of 65. You should get 110.3. So x equals 110.3. Down below, part B. If the string on the kite is 200 feet long, so the string is 200, how far away must the person flying the kite stand from the center of a closed-off area, assuming the angle of depression is 25 degrees? So if this is 25, remember, that's 25. This has to be 65. We're wondering how far this length is here. So we have to take the sine of 65 is equal to x over 200. You just have to multiply 200 times the sine of 65, and you'll get your answer, 181.3 feet. Okay.